Hi dears, this is Raji. In the previous video, we were learning about the importance of organic chemistry, the catenating property of carbon also. Today, we are going to see what makes carbon so different from the other elements so that carbon is capable of forming huge number of compounds whereas others cannot do that. Let's see that also. As we are learning organic chemistry from the very beginning, we need to understand few more basic concepts related to that. Okay, we already said that carbon is capable of forming large number of compounds by means of covalent bond. It can self-link with each other by means of covalent bonds, we said. What is that property known as? That is known as catenation. Correct, no? Okay, Now, we are going to see why carbon is incapable of forming ionic bond. Question will come to mind. Or why this carbon-carbon bonds are only covalent in nature. Okay, that's a question. Now see this picture. This is a metal. Okay, And the other one is a non-metal. So metals are electron donors and non-metals are electron acceptors. Okay, that is, if the metal is missing that electron, it will become a cation. Okay, it will be having a positive charge. Why? Because it has a shortage of one electron. And whenever an atom is accepting electron, it will become negatively charged. Why? Because it is gaining one electron. And this is known as anion. Once it has become anion and a cation, it will start attracting with each other. Okay, it will be held together by strong force of attraction. That is electrostatic force of attraction, and we call that force of attraction as ionic bond. Got it? Okay, so remember, an ionic bond will be formed only by the complete transfer of electron. Okay. Now we are going to check whether carbon is capable of forming this kind of ionic bond. Okay, for that write the electronic configuration of carbon. Atomic number 6, electronic configuration is 2,4. Observe this carbon atom little bit closely. Do you think, okay, carbon is happy? No, it is unhappy. What is the reason? It has got only 4 electrons in its valence shell. Okay, So as per the octet rule, an atom can attain stability and can become happy only if it is having 8 electrons in its valence shell. And we call it as octet configuration. Correct, no? Otherwise, it can have 2 electrons in its valence shell to have a duplet configuration. Got it, no? It is just like helium. Helium is a very stable element. Now let's see what carbon will do to attain stability. For that, one more time write the electronic configuration of carbon. It is 2,4. Imagine, it is going to accept 4 electron from some other atom. Then what will be the new electronic configuration? Write it. It will become 2,8. Now carbon is happy. But one problem is that, what is the number of proton inside the carbon atom? Number of proton is only 6. Okay, But what is the total number of electrons now? After gaining 4 more electron, it has become 10. Okay, So we can say that 6 positive charge is balancing with 10 negative charge. It will not be balanced, right? No. Lot of electrical imbalance will be created inside the system. So this will make carbon atom highly unstable. So carbon will never do that. Okay, It is trying to attain stability, right? Okay, So it will never go for that. Got it? Now, what will be the other possibility carbon is going to try? Now, this is the present electronic configuration. It is giving away this 4 electron to some other atom. Then, what will be the new electronic configuration? It has got only 2 electrons in its valence shell. Got it? That time also, what will be the number of proton? 6 only. It is not going to change. Okay, protons are inside the nucleus. So 6 positive charge will be there. Okay, And what is the number of electron? Electron will be 2. Okay, So this also will create lot of electrical imbalance. So what will happen? This time also carbon will become unstable. Got it? So what we are trying to tell, why carbon is not capable of forming ionic bonds. It can't accept 4 electrons all on a sudden, and at the same time it can't give away 4 electrons to someone else. At a time. What is the reason? Yeah, that will make the system highly unstable. So we came to know that carbon cannot attain stability by accepting 4 electron or by giving away 4 electron to someone else. Okay, so but carbon also has to attain stability, no? Poor fellow. So who is approaching? By the time hydrogen atom is approaching there. Hydrogen is also unhappy. What is the reason? It has got only 1 electron in its valence shell. Okay, and see, its intention is to have 2 electrons in its valence shell. Okay, so that it can attain a duplet electronic configuration. It doesn't have much bigger dreams. Okay, if it is having 2 electrons in its valence shell and attaining a duplet configuration, hydrogen also will become happy. So how many hydrogens are approaching this carbon atom? 4 are coming. Okay, see, write along with me. This is hydrogen and this is the electron of hydrogen. Another one, like that, 4 are coming. See, these 4 hydrogen atoms are willing to share electrons with carbon atom. Now, see, if so, count and see. If you are including, the electron of hydrogen atoms also, total how many electrons are there around carbon? 1, 2, 3, 4, 5, 6, 7, 8. 4 from carbon and 4 from hydrogen atom. Now carbon is happy, no? Okay, but think about hydrogen. See, hydrogen is also happy. Okay, that is mutual sharing is taking place. Correct? So hydrogen also attained a stability by the duplet configuration, whereas carbon also attained stability by octet configuration. Got it? Okay, so remember, whenever a pair of electron has been shared, see, this is the electron of hydrogen and this is the electron of carbon. Whenever a pair of electron has been shared between 2 atoms, that will result in a bond. How we will write? That is a covalent bond. So now carbon has attained stability by the formation of covalent bond or by the sharing of electrons. You can just remember. And one more point to be remembered, carbon has the capability to form double bond as well as triple bond also. Okay, what is a double bond? 2 bonds will be there between carbon atom. That means whenever one pair of electron is shared, it is a single bond. Like that, 2 pair of electron has been shared. What will happen? That will result in a double bond. And it is capable of forming triple bond also. Okay, then what will happen? How many bonds will be present between carbon? 3 pairs of electron has been shared between carbon. That will result in a triple bond. Okay, one smart fellow was asking me one day, ma'am, why carbon cannot form 4 bonds with each other? See, 4 valence electrons are there around carbon. Okay, so both of them can share these 4 electrons, okay, together, and it can make it can attain stability. Okay, but it is not possible. Okay, maximum 3 bonds will be there between 2 carbon atom. Why 4 bonds are not possible? See, whenever a single bond is formed, okay, this is the distance you can think. Whenever a double bond is forming, the attraction will become much more stronger. These carbon atoms are coming much more closer. Whenever a triple bond is forming, what will happen? They are coming much more closer. So whenever 4 bonds are present, what will happen? Carbon and carbon will come much more close together. Okay, so that time what will happen? The nucleus of one carbon atom and the nucleus of other carbon atom will start repel each other. Got it? Okay, so that point also you can just remember. We came to know that carbon has the ability to combine with each other, resulting in the formation of huge number of organic compounds. What is that capability known as? The property to self-link with each other. That is known as catenation. Okay. Now the question is that why only carbon is making this kind of covalent bonds, and that also they are so strong also, whereas other elements are incapable of doing that. For example, consider group 14 element. Carbon is the first member of that group. Atomic number is 6, electronic configuration is 2, 4. Consider silicon. Silicon is 14. Electronic configuration 2, 8, 4. See, both are having 4 electrons in its valence shell. Silicon also can form 4 covalent bonds around it. Okay, by sharing this 4 electrons with some other atom. But the question is that silicon will not form this kind of huge compounds. Okay, whereas carbon is capable of forming that. What is the reason? Okay, yeah, see this picture. There, imagine all these are carbon atom and all these are silicon atoms. Silicon atoms are much bigger in size. Okay, now, yeah, again draw one more time. One carbon atom. This is one carbon atom and this is another carbon atom. In between two carbon atoms, like we know that a covalent bond will be present. At the end of a covalent bond means a covalent bond is formed by the sharing of two electrons. So one covalent bond means like two electrons will be there. Now imagine, yeah, the size of this carbon atom is much more smaller. Okay, yeah, what will happen? It can easily attract this pair of electron more effectively towards it. Whereas like these pair of electrons will be attracted by this nucleus also. So these two electrons are strongly held by two carbon atoms, we can say, or that covalent bond is, yeah, much more stronger. Got it? Okay, yeah. Whereas, yeah, what will happen over here? Yeah, this silicon atom is much more bigger. So, okay, the nucleus, this is a silicon atom and this is another silicon atom. Yeah, and in between also one covalent bond will be present. Okay, yeah, then what will happen? This pair of electron, yeah, cannot be attracted towards the nucleus effectively. What is the reason? Yeah, because size of the atom is much bigger. In order to make the idea much more clear, I will tell you one more example. Imagine a classroom. Okay, yeah, there was a famous teacher in the classroom. Okay, yeah, so in order to attend that teacher's class, so many students are coming. As a result, what happened? Yeah, her classroom became, yeah, so big. Okay, yeah, but at the same time, one more problem started. Those who are sitting in the back bench, okay, started creating some problem because, yeah, teacher can't control these students. Okay, what is the reason? Because all other seats in front of them, okay, it is completely full. So teacher can't pay individual attention for the students. Consider this teacher as the nucleus and this as the, yeah, pair of electron. Whenever the size of the atom becomes much bigger, what will happen? The force of attraction, yeah, towards the nucleus will be considerably reduced. Now what happened? Teacher came to know that, okay, yeah, so she restricted the seats in the classroom into two rows. Okay, yeah, so what happened this time? Yeah, she can pay individual attention. We can say that if this is the nucleus and this is the electron pair, okay, yeah, this will be much strongly attracted towards it. Got the idea? Okay, yeah. So why carbon-carbon bonds are more stronger? Because of the, yeah, smaller size, or you can write that, yeah, it is because of the compact size of carbon. Okay, yeah. See this question, why carbon-carbon bonds are covalent in nature? Read the second one also. Give reason why carbon cannot form C4 plus and C4 minus ions they are asking. See, the question is different but answer is same only. Got it? Yeah. So how to write the answer? You will write the electronic configuration of carbon, that is 2O4. Okay, yeah. In order to form C4 plus ions, so it needs to give away this 4 electron to some other atom. So what will be the electronic configuration that time? Only 2. Okay, then you can tell that. But still, proton inside the atom will be 6 only. And the electrons inside the atom will be equal to 2. 6 positive charge and 2 negative charge will be there in the atom. So too much of difference in positive and negative charge will make the system unstable, you can write. Got it? Yeah. Now what is the another possibility? C4 minus, that means it has to accept 4 electron from somebody. Okay, that time what will be the electronic configuration? It will become 2 8. But that time also number of protons will be 6 only. 6 positive charge. What will be the number of electron? That will be equal to 10 negative charge. So yeah, too much difference in positive and negative charge will make the system unstable. Now see this one. Give reason why carbon-carbon bonds are more stronger than silicon-silicon bonds. Okay, yeah, what answer will you give? You can tell that, yeah, that a carbon atom, because of its smaller size, that electron pair that are involved in covalent bond will be, yeah, attracted more strongly towards itself, whereas silicon atom being much bigger. Okay, what will happen? The electron pair will be less effectively attracted towards the nucleus. Okay, so then next one, why do organic compounds, yeah, have generally low melting point and boiling point? We need to remember, if you have an organic compound, say methane, in this container, Okay, yeah. So, and they are asking about the melting point and boiling point. So that time we will have to speak about the intermolecular force of attraction. That means how one molecule will be that attracted or held together by another molecule. So we call it as van der Waals force of attraction. This is a very weak force of attraction. Okay, yeah, because of that, with very less temperature, yeah, what will happen? Yeah, that see bond between or the force of attraction between the carbon compound will be broken down. Okay, yeah, and easily, yeah, they will be getting converted into liquid and gaseous state. Okay. That is the reason I said in that last video also, organic compounds are highly volatile. In the same way, yeah, whatever we are learning also will be highly volatile from memory. So what we need to do, we will have to write and learn. Thanks for watching. See you in the next video.